I am Dr. M. Sangeeta, Associate Professor, SRM Madurai College for Engineering and Technology, Madurai. The topic is about disk scheduling in operating systems. This topic is very important and easy to understand. First, we will see what is meant by disk scheduling. Disk scheduling is defined as it is a fundamental element of operating machine design and crucial for optimizing the performance and efficiency of input and output operations. This figure easily explains how the job requests are assigned to the disk. And also, disk scheduling algorithms are crucial in managing how data is read from and written to a computer's hard disk. These algorithms help to determine the order in which disk read and write requests are processed. Next, we will see what are the available disk scheduling algorithms. The available disk scheduling algorithms are first come first serve algorithm, shortest seek time first algorithm, scan algorithm, C scan or circular scan algorithm, look algorithm, C look or circular look algorithm. These are all the several disk scheduling algorithms in operating systems. We will discuss in detail each one of them. First come first serve disk scheduling algorithm. It is very simplest of all disk scheduling algorithms. In FCFS, the requests are addressed in the order they arrive in the disk queue. Let us understand this with the help of an example. Suppose the order of requests are 82, 170, 43, 140, 24, 16, 190 and the current position of redundant head is 50. So now we have the cylinder size is 200. So it has been slitted from 0 to 199. So the given request has been specified and presented from 0 to 199 of cylinder size. So in the first come first serve, which is arrived as a first one, that will be processed as the first one. So from the current position of redundant is 50. So it is starting from the current position of redundant, then it is moving to the second position of the first come to 82. Then from the 82 it is moved to the 170 process request. From the 170 it is moving to the 43, that is the next one. After the 43, we received 140. So it has been moved to the 140, then 150, then 24, then 16, then finally it is reaching at the end of a process request which is arrived as the last, that is 190. This is how first come first serve scheduling algorithm is presenting. Next we will see shortest seek time first scheduling algorithm. In SSTF, requests having the shortest seek time are executed at first. So, the seek time of every request is calculated in advance in the queue and then they are scheduled according to their calculated seek time. As a result, the request near the DISCOM will get executed first. SSTF is certainly an improvement over FCFS as it decreases the average response time and increases the throughput of the system. Let us understand with the help of an example. Suppose the order of request as we have in that FCFS, the same requests are given in this example also 82, 170, 43, 140, 24, 16, 190. So the same cylinder size and the current position of redundant data also same. So in this it is moving from the 52, the next shortest seek time is 43. So it is moved to the 43, then it is moving to the 24, then 16. After that 16, it is moving to the next shortest seek time, that is 82, then 140, then 170, then 190. So this is how shortest seek time is scheduled. Next we move on to the scan scheduling. So this another name is elevator algorithm. In the scan algorithm, the DISCOM moves in a particular direction and services the request coming in its path and after reaching the end of the disk. It reverses its direction and again services the request arriving in its path. So this algorithm works as an elevator and is hence also known as an elevator algorithm. As a result, the requests at the mid-range are serviced more than and those arriving behind the disk arm. we'll have to wait. In example, we can check from the current position of the disk, it is starting from the 50, then it is moving to the next request of the 82, then 140, then 170, then 190. Finally, it is touching the end of the disk of 199. Then again, the given process request only moving from the current position. So that is 43, 24, and finally it is touching the end of the request, not end of the disk. So this is how scan scheduling algorithm is presenting. Next, we move on to the circular scan scheduling. In scan algorithm, the disk arm again scans the path that has been scanned after reversing its direction. So, it may be possible that too many requests are waiting at the other end, or there may be zero or few requests pending at the scanned area. These situations are avoided in the C-scan algorithm, in which the disk arm, instead of reversing its direction, goes to the other end of the disk and starts servicing the request from there. So, the disk arm moves in a circular fashion, and this algorithm is also similar to the scan algorithm, hence it is known as a C-scan algorithm. So, from this we can easily understand how it is moving from the current position 50. So, from 50 it is moving to the 82, 140, 170, 180. These are all the given requests. Then it is touching the end of the disk, that is 199. Then it has to be circulated at the left end of the disk, that is 0. After touching the left end of the 0, that is the end of the disk, then it is moving as per the given request 16, 24. Finally it is touching the end of the request, that is 43. So next we move on to the look scheduling. Look algorithm is similar to the scan disk algorithm, except the difference that the disk, in spite of going to the end of the disk, goes only to the